Mars didn't turn out to be as quiet as it was initially thought. Instead, the red planet is rumbling and grumbling with powerful seismic activity. Deep below its surface, the planet is witnessing dynamic tremors, and even today, there might be hot lava flowing just beneath the Martian crust. If it turns out to be accurate, it will change our understanding of Martian geodynamics acquired over the years and suggest that volcanic activity on the red planet is not just possible, but is still occurring, and that too more frequently than expected. But what does this rumbling signify? How will it change our understanding of the Martian geology? Finally, and most importantly, how will this groundbreaking discovery impact our search for past and present life on Mars? Around 3 to 4 billion years ago, Mars was a hot spot for volcanism. During this period, it spewed enough volcanic debris from its interior to form one of the largest volcanic structures in our solar system, Olympus Mons. It's a volcano nearly 3 times the elevation of Mount Everest. However, most of the volcanism was believed to have occurred only during this period. A few minor eruptions occurred in isolated locations, perhaps as recently as 3 million years ago. A planet's magnetic field is an outcome of its internal activity. Since Mars doesn't have a global magnetic field, it solidified the argument that Mars's interior is no longer active. In short, for years, there was no evidence to indicate that Mars could still be volcanically active. But 2018 marked the beginning of a new chapter in our exploration of Mars. NASA launched the InSight mission, specifically designed to study the deep interior of the red planet. The lander consisted of some highly sensitive seismic experiments, and the initial data set sent by the lander gave us the first direct evidence of Mars quakes. Although the first tremor wasn't strong enough, over 235 Martian days or sols, the instrument on board recorded 174 Mars quakes. Fast forward to 2022, the InSight lander has detected over 1,300 quakes on Mars. The type of tremors occurring on a celestial body can reveal much about its interior makeup and activity. So, to understand better what is happening precisely inside Mars's belly, researchers conducted a close study of a cluster of 20 recently detected quakes. The data suggested that most of the faults distributed across the planet are not seismically active. But along with that, the researchers also caught hold of something fascinating. The cluster of quakes seemed to have originated in a region called Cerberus Fossae. It is a fissured area of the planet named after a creature from Greek mythology, known as the Hellhound of Hades, which guards the underworld. Now, this is where things turn interesting. This region consists of some features called graben. Here, the tectonic activity forces the faults to open up. Due to this opening, the blocks of crust slip down between the parallel ridges of the faults. The deeper seismic waves had a low frequency, while high-frequency quakes were recorded along the sides of the Cerberus Fossae graben. So based on the seismic data gathered by InSight, the team concluded that the low frequency of the deeper seismic waves indicates the presence of a warm source region, some 30 to 50 kilometers below the Martian surface. This warm region is consistent with molten magma that hasn't cooled down, which hints at a recent or present-day seismic activity. Following this, the researchers inferred that the terrain in this region is sinking under its weight, forming parallel rifts that pull the Martian crust apart. The information drawn from Cerberus Fossae quakes is crucial because they represent at least half the seismic activity present on Mars. Further, when the InSight data was matched with the orbital images of Cerberus Fossae, The quakes were noticed to have occurred very close to a structure in the Cerberus Fossae mantling unit, previously designated a young volcanic fissure. Around this feature, researchers spotted deposits of darker dust. This dust was possibly scattered out in multiple directions from the fissure, and the darker shade signifies that the geological evidence of Mars is pretty recent, perhaps within the past 50,000 years. These results suggest that geological activity and volcanism still play an active role in shaping the Martian surface. However, not all the rumbling on Mars is due to internal activity. For example, among more than the 1,300 quakes detected by InSight, one tremor resulted from a meteor impact. On the eve of Christmas in 2021, a meteor crashed into Mars and shook the planet so much that NASA's InSight lander recorded the rumblings. For a long time, the origin of this quake wasn't figured out, but recently, the Mars Reconnaissance Orbiter captured images of a brand new impact crater on the planet. The crater was found to be about 500 feet wide and more than 10 times larger than the typical new craters we usually see forming on Mars. In addition, there existed boulder-sized blocks of water ice around the crater, which possibly kicked up from beneath the surface in the explosion. Our growing understanding of Mars has shown that the planet has changed significantly over its 4.5 billion-year lifespan. The presence of aqueous minerals has suggested that Mars was once awash with liquid water, which means that the present-day windy red dust ball might have been habitable in the past. Even today, liquid water lakes might be present below the surface, where life is flourishing. And if such biospheres exist on Mars, they must require some heating source to maintain a habitable temperature, and hot liquefied magma can be a perfect source of that heat. Detecting quakes near the Cerberus Fossae region of Mars could be one of the most critical events in InSight's mission. So far, the lander has made significant contributions towards understanding the geology of Mars. But sadly, it might no longer be able to do that any further. For the last 4 years, Martian dust has been accumulating on the solar panels of the InSight lander, and recently, it was hit by another dust storm that could have been the final nail in the lander's coffin. So, InSight will likely run out of energy soon, bidding goodbye to this journey of exploration of Mars. This concludes the 33rd episode of the Sunday Discovery series. So, if you've enjoyed this video, make sure to like it, subscribe to our channel, and press the bell icon so that you don't miss any future videos of this series.